All right, this is lesson 5.2. This is the second video. And we're just going through different types of problems you're going to ask in this section, just practicing simplifying trig functions. Another set of directions is going to say something like this. Simplify. And how will you know when you're done? When you get either a constant or get it down to a single trig function. And this time they're a little more liberal with it. It doesn't have to be sine or cosine. But if you get it down to a single trig function, you are done. So let's try something like this. Tangent times cosine. You might remember this from section 1. We took out tangent and said, isn't tangent sine over cosine? And again, you kind of looking at your identities. And when you look at those fundamental identities, you had a couple to choose from for tangent. But I kind of opt for the ones with sines and cosines in them. So tangent is sine over cosine. It's times cosine. And since I have a fraction, I'll put the cosine over 1. And look at that. The cosines cancel out. And I end up with, I multiply my fractions. This simplifies into just sine. And I know I'm done when I get a single trig function or a constant. That's a single trig function. I am done. Next one. Secant squared minus 1. And again, those squares are always a good hint. So let's look back at those Pythagorean identities. And the Pythagorean identities, here's one with secant in it, right here. So secant squared is tangent squared plus 1. And you can do some algebra on it here, but I'm just going to keep that. Secant squared is tangent squared plus 1. So secant squared, I'm going to take out the secant squared. And the secant squared is the tangent squared plus 1. I'm going to sub that in. Then I have a minus 1, which is from here. So the secant squared was the tangent squared plus 1. And you can see the plus 1 minus 1 cancel out. And I get the tangent squared. And this is a power of a single trig function, but that's just as good. So I'm down to a single trig function again. I can stop. So if you take something, you get it down to a single trig function or a constant, you are done. Look at this one. 1 over tangent squared plus the cotangent times the tangent. And again, do you have those fundamental identities at hand? And if you do, what catches your eye? And maybe over here, this catches your eye. Tangent and cotangent. What do you know about tangent and cotangent? Do you know tangent and cotangent are reciprocals? Do you know what happens when you multiply a reciprocal? So 5 times 1/5 is 1. 7 times 1/7 is 1. So tangent times cotangent, what is that going to be? Those are reciprocals. When you multiply reciprocals, what do you get? You get a 1 when you multiply reciprocals. Okay, how about this? 1 over tangent. Well, the reciprocal is cotangent. So I'm going to go cotangent squared plus 1. You could have done this other ways, but here's a nice way to do it. 1 over tangent is cotangent. Cotangent times tangent, reciprocals, gives you 1. Oh, look, I've got a square in this, the cotangent squared. Do you got those Pythagorean identities? And what's the cotangent squared? All right here. 1 plus the cotangent squared is the cosecant squared. And what do we have here? Look at that. 1 plus the cotangent squared. That equals the cosecant. Oops, that's a square. Cosecant squared. And once you get it down to the power of a single trig function, you can stop. Kind of fun problems to do. It's like little puzzles we're solving. Okay, a few more of these just to practice these. And this time it will say verify the identity. And what that means is they're giving you the answer. And we just got to work with the complicated side and work with it until it looks like the simple side. And the question always comes up, well, which is the complicated side? And I would say the side that has the plus or minus typically is the more complicated side. And so I look at this problem, I look on the left side, I've got a cotangent plus a tangent. The right side, I've got a secant and cosecant. There's really no relationship between these. There's nothing in common between the two. When that happens, I guess I like to switch to sines and cosines. So cotangent. What's the cotangent? That's the cosine over the sine. What's the tangent? It's the sine over the cosine. And again, I'm working exclusively on the left side. And I'll know I'm done with the left side when it looks like the right side. Okay, adding fractions. How do you add fractions? Get a common denominator. We've done that a couple times. Still good practice. Myself a little space there. So I'm going to get a common denominator of sine, cosine. The first fraction, I've got to multiply the top and bottom by cosine. Gives me cosine squared. This problem might seem familiar. Second problem, I've got to multiply by sine. Top and bottom by sine, I get sine squared. I can now add up the fractions. On the bottom, I've got sine x cosine x. On the top, I've got cosine squared plus sine squared. And again, you want these fundamental identities just at your fingertips. And you see those squares, and you're thinking, is that an identity? Sine squared plus cosine squared? Yes, it is. Look, it's right here. Sine squared plus cosine squared, that's 1. So sub that out. Put in a 1. So on the top, I've got 1 over sine times cosine. And then you remember your reciprocals. What's 1 over sine? That's the cosecant. What's 1 over the cosine? That's the secant. And look, guys, my left side matches up with my right side. I am now officially done. And again, you want to work on one side and keep working and working and working and working and working until it looks like the other side. And I would say the more complicated side is usually the side where you have to add or subtract. All right, that was fun. Let's do it again. How about this? Cosine over the sine times the cotangent equals 1. Hopefully we're clear, we'll agree this is the more complicated side. And how do you begin a problem like this? Well, I've only got a 1 on the other side, so I think I'll look for sines and cosines again. And the cotangent, would you guys agree with me? It's the cosine over the sine. So I'll take out the cotangent, and I'll sub in cosine over sine. And maybe now you start to see your way through this problem. What happens on the bottom of the fraction? Sines just canceled out. What am I left with? Well, I'm left with a cosine on the top. And in the bottom, I'm left with a cosine. Wait a minute, what's cosine divided by cosine? It's 1. And once your left side equals your right side, you have simplified or you have verified the identity. All right, one last problem, I believe. Yep, this is it. Last one, and this is one to really push you a bit, and that's okay because so far, hopefully it hasn't been too bad. Sine over 1 minus cosine minus sine cosine over 1 plus cosine, and show it equals that thing on the right side. My goodness, this is complicated. Both sides are complicated. I would kind of lean towards this side because you got that minus separated into two functions. And you've got a plus here, I know, but look, these are fractions over here. So if you had to choose the complicated side, I think you'd have to lean towards the left side. All right, how do we subtract fractions? Same way we add fractions. Get a common denominator. And this alone is very good practice. Let me just reset. There we go. So 1 plus cosine x will be our common denominator. 1 minus cosine x. 1 plus cosine x. There we've got our common denominator. The first fraction, I've got the sine. I better multiply by 1 plus the cosine of x. Second fraction, I've got the 1 plus cosine. Got my minus here, so I better multiply by 1 minus the cosine. And again, I'm working exclusively on the left side. All right, I've got a common denominator, so I'll write that. 1 minus cosine x, 1 plus cosine x. So far, so good. And now on the tops of the fractions, I'll first distribute. And when I do that, you see at first on the top, I've got a sine x times 1, sine x, plus sine x times cosine x. So sine x, cosine x. Second fraction over here, when I distribute, I'll get sine x cosine x times 1, and I'll get minus that cosine x. So I'll distribute that. While I'm distributing, I'm also remembering there's this minus sign in front of that whole second fraction. So I distribute the first part here, sine x cosine x times 1. I've got that minus sign, so it's minus sine x cosine x. I'll extend that fraction a little bit. And now I multiply the second time, sine cosine times cosine. I get sine x cosine squared. And it turns out there was 2 negative signs, one here, so that's a plus. Okay, anything on top cancel out? Yes, it does. Sine x cosine x minus sine x cosine x, that's gone. We're making progress. So on the top, I'm left with the sine of x plus the sine of x times the cosine squared of x. Doesn't look too bad. All right, let's work with the bottom a bit. And again, just looking over here at our final answer, what we're trying to get, there is no bottom, so this bottom must simplify somehow. Let's FOIL this out. First gives me 1. Outside gives me cosine x. Inside is minus cosine x. And last is minus cosine squared of x. Difference of two squares, you might remember that. I got to scroll that up a little bit. Give myself just a little more space. All right, let's keep working on the bottom here. So the top for right now, I'll keep the same. Maybe you see one thing you can do on the top. If you're thinking factoring, I am too, but let's just let it go for right now. All right, on the bottom, cosine. Minus cosine goes away, and I get 1 minus the cosine squared of x. All right, could I simplify that? Well, Pythagorean identities. What's 1 minus the cosine squared? I don't know, but right in here I think I've got something. Sine squared plus cosine squared is 1. Subtract cosine squared from both sides. Do a little bit of algebra there. So subtract cosine squared. And look at that, guys. 1 minus the cosine squared is the same thing as the sine squared. So that whole bottom, 1 minus the cosine squared, it simplifies. And 1 minus the cosine squared is really the same thing as sine squared. We are getting there. All right, on the top. What do both of these have in common? They have a sine in common. I'll factor that out. I've got sine x. If I factor out the sine, the first term has a 1 left. The second term has a plus cosine squared of x. Let's cancel out one of the sines. We do that, and I get 1 plus the cosine squared of x over the sine of x. Guys, we're almost there. We look back up at the top one, and we realize the top one, they have no denominator here. Look at the right one, I'm sorry. There's no denominator, but that's okay, because 1 over sine, having a sine on the bottom, is the same as having the reciprocal, the cosecant on the top. So 1 over sine is the cosecant of x times 1 plus the cosine squared of x, which is what we were trying to verify. So that last problem took a little bit, but the ones leading into it were not bad at all. So this completes section 2. This will take a little bit of practice, but it all depends on you knowing those fundamental identities. If you have those at hand, this will go very smoothly. All right, that will complete lesson 5.2.